30 minutes late, so we can get started.
Okay.
All right, let's share my screen. Can you see my screen?
Yep.
Okay, so good thing is I managed to do the PDF of that issue last time, you know. So we are
That's
good.
good.
This time good. We can look at the answers and the questions same way. Okay, so this portion we're going to use for the questions, and this guy we're going to use for the answers. Okay, on the right hand side. So we finish until question number 10. So we all done. So anybody wants to discuss anything out of this first 10 questions, feel free to shout. Otherwise, we'll move on to the next question, which is 11th. All good?
What's the page number on the textbook? Or I forgot the lesson. What lesson is this?
Okay, so we are doing the lesson 12, exercise lesson 12. The page number is like this guy's copy of this, so I think it's.
Yeah, I got it. With question 12, right?
11th.
Yeah.
11th.
Okay, 11. Okay.
Yeah. So when would you need to create a dynamic Keras model? Or how do you do that, and why not make all models dynamic? So first one. So why do we make the models dynamic?
Yeah, I don't know what that is.
I'm like, you remember, I think in a fast AI, we did the callbacks. Would it be related with the callbacks when you want to dip into every step of an epoch or every batch? You want to get the value out of it, sort of like debugging, or maybe you want to update something before batch, after batch, before epoch, after epoch, all that sort of stuff. Perhaps then you use the dynamic Keras model, I guess.
But why would that make the model dynamic?
Dynamic in a sense. Okay, so then we need to go back to the definition. What do we mean by a dynamic model then? Dynamic
Because
model.
callback is just you want to perform some particular action at the end of each epoch or at the end of each batch or start of epoch, something like that, right?
Yeah.
Not sure if it makes it dynamic.
But wouldn't that be based on the input or output? So in a sense, if you want to make before or after, that dependent on what you are getting the output. So in a sense, if you just know what you're going to do, so why not to push it to the model itself? But the callback would be effective only when you don't know what's going to happen, but you are looking to, based on the situation or a context, you will run your functions and so on. So that's the dynamicity. Again, that's my perception. That's my idea. I'm open for, you tell me, what do you think?
Yeah, I don't have much idea about this. But I have seen callbacks being used to like modify the learning rates and stuff dynamically. So I mean that's kind of making the model dynamic, right? So maybe you're right.
Yeah. Anything you want to add, Arto?
Oh, I don't quite remember what dynamic means. So
it's just weird. It's just throwing our own idea. We don't remember either.
Yeah.
All right. Let's read through the answer then. Okay. So this is the answer on the right hand side.
Maybe we can just pick in the answer at what does he mean to be dynamic for Keras model, and then we can like to think about it a bit more.
Yeah. So let me read it aloud. So create a dynamic Keras model can be useful for debugging, as it will not compile any custom component to the TF function. And you can use any Python debugger to debug your code. Okay, so one thing he's saying is like it's if you make a debugging active, then you may make it as a dynamic. And I think TensorFlow functions, which we discussed last time.
So basically, it does not create the computation graph. Is that what it means?
Okay, yeah, now it makes sense. So I think the difference is in TensorFlow, the computation graph is static, unlike in PyTorch. In PyTorch, I think that like computation graph is created for each time when like we call the computation, when we do the computation. And in TensorFlow, we create a static computation graph. And if you don't want to create a static computation graph, if you want to keep this dynamic, you can pass special parameter. Now it makes sense.
And it says in here that you say run eagerly is equal to true, or like I think there is a dynamic is equal to true. So it can.
Another question. So are TensorFlow models slightly faster than PyTorch? I mean, shouldn't it be theoretically, if it already has a static computation graph by default, and PyTorch is always dynamic?
Yeah, in my experience, at least with, I don't have much experience with TensorFlow. I didn't have much experience with TensorFlow lately, but I did some exercises some time ago for these chapters of the book, and I think like execution time was faster for TensorFlow models.
Interesting.
Yeah, but it would be interesting to like make some like benchmarking of both.
Okay, so it can also be useful if you want to include arbitrary Python code in your model, as in your training code, including call to external libraries. So, and that call to external library would be the perhaps is the callback. Do you think? Well, we can call anything.
I think what they say is you can just you can just add any Python function in the model.
Yeah.
So, but if you want to make it a static Keras model, it has to be a TF function. You cannot just add any Python function.
Correct. That's what we discussed last week. Yeah.
But a callback is not part of the model, right? You can correct me if I'm wrong. It's not part of the model. It's just something. It's just a function that gets executed at the end of an epoch, at the end of a batch. It's not part of your model.
Yeah.
So that can be anything. That need not be a TF function. That can be any old Python function.
Yeah. Yeah. No, you're right. Yeah. Correct. To make model dynamic, you must set dynamic is equal to true when creating it. Alternately, you can set run eagerly is equal to true when calling the model compile method. Make a model dynamic prevents Keras from using any TensorFlow's graph features. So it will slow down training and inference. So as you were saying, Gautam, that the dynamic model, Keras model will be slow, and then static, which is by default the TensorFlow is faster. So, and you will not have the possibility to export the computational graph, obviously. Yeah. which will limit your model's portability. Yeah.
But these days there is some other thing called ONNX thing. Like you can just export your PyTorch or TensorFlow model as an ONNX format, and then yeah, you can interchange it between frameworks. Like you
Yeah,
can export TensorFlow to ONNX and then that ONNX to PyTorch.
correct.
Yeah.
However, yeah, so well, in a sense, you mean this statement doesn't hold true then? Because if you say ONNX, you can port to.
Yeah, I don't exactly understand in what way it limits the portability.
Hmm. That's a question to ponder.
Yeah. I mean, you can always save your model and move it around, right? I don't understand that statement.
Yeah, I have no clue either. Not very well explained either here. So I don't know how it affect the portability. I need to see. I think it's probably something to
So,
explore for that. Go on.
so does it mean that if your TensorFlow model is dynamic, you can't save the model? You can't save it as a, yeah. You can't save the model to disk?
I think you should be able to. That's what we did initially. Like we did the customization and we saved it, but I don't think
Well, I'm not
portability.
sure that custom Python functions would be imported. If you're familiar with FastAI applications, you know that if, for example, if you define some custom functions which would be you would need when doing inference, and when you do learn.export. Custom functions are not serialized together with all the model.
Yeah.
And then you, for inference, you need to redefine your custom functions in the environment where you do the inference. And I think something similar is going on here. Like when you have a proper this computational graph, then TensorFlow will take care of serializing everything and making sure all of what you use is exported and then imported when you do import. But if you use this dynamic style, then you lose this integrity of the model. And you may have to take care of some imports yourself.
Yeah.
Yep, that makes sense. Yeah.
Yeah, but one thing which I wanted to look is so low losses and metrics on the model internals. You remember when we were building the custom modules, he talked about something called, I think, save configuration and a get configuration, and where he specifically went through that when you save it. So you see this get configuration. So when you write this model, when you have a custom model, you need to have this get configuration, and I think there is another function called a set config. So in a sense, if you want to save the any custom piece, that's what I'm looking here. He mentioned somewhere, so called build. Yeah, I think down below.
I think the config is the set of hyperparameters that you want to reuse, right?
Correct. that's the custom piece. So in a sense, if you have the custom parameters, which you, let's say, if you have the parameter is x has a value 5, so you need to save them with the set config. And when you save it, and then when you import the model, then get config will bring up all the hyperparameter as well as the values. So I'm just thinking, wouldn't that hold true as far as the model is concerned when you're saving a model? Because it's a configuration part. You know what I mean?
Yeah, but I think what Arto is talking about is slightly different, right? There, if there is a function that is part of your model, and if that function is not part of your computation graph, then if you save the model, that function part is not saved. So you'll have to recreate that function again if you're
Okay.
loading it in a new environment. This is similar, but it's talking about the hyperparameters in particular.
Yeah, I think those are related like issues because in both cases, if you do something like custom, you need to take care of proper serialization. So you need to make sure everything is stored.
Yeah, I think so that's the general gist. I think if you're doing any customization, perhaps you can store it. I don't know.
But
Maybe.
here the hyperparameters are actually stored to disk. So can
Yeah,
we actually store a Python function also?
as a part of
Yeah,
the computational graph.
yeah, I don't think that is talked about in this book. Maybe, not sure.
Yeah.
Yeah, I'm still not 100% sure how it is done best with FastAI, for example. How can you avoid this redefinition of functions in your inference environment? So
What I don't get is in what scenario is a dynamic model useful? Like, when do you have these custom functions? Why can't you just, I mean, to me, it seems it's better to have the default computation graph. Even in PyTorch, it's better to use, I mean, better to avoid. I don't see any situation where something so custom is needed.
yeah, he mentions debugging. So maybe if you want to put a breakpoint in your code, it wouldn't work because like Python debugger, it's basically placing some Python code in your TensorFlow module, and it wouldn't work if it's all compiled to a static graph. But if you run eagerly and Python code is run, then you can use all the debugger functionality.
Okay.
But again, I don't have any like practical experience with TensorFlow, and that's just like my speculation. How would it work? But I clearly remember that when you convert something to TensorFlow function, you only can call Python code when it is like at setup of the graph, and it is every Python like code is called only when graph is compiled, but then only TensorFlow functions, like converted functions, would be called. I think that it was somewhere in the book. So yeah, it might be like that.
Okay. Okay, that's a good explanation. All right, let's move on to the exercise part. Okay. So the question number 12 is actually given in here. So I have this guy here. So what we can do is maybe all of us open this guy and then maybe walk through the question as as he says the question, and then we can walk through here, and then perhaps try running it as well. I before coming in here, I had a go on it, ran a bit, so I ran into a issue as well. So I want you to run this as well to see if you're having an issue as well or not. I'm having an issue, I think, in somewhere in third C or a B. So open this as in Collab, and then we'll walk through questions. Everything is given here, so we'll just run it, but we'll walk through every step. Does that make is it good for you both?
Yeah.
Okay, question number 12, and if you want, I can send you the link actually.
Yeah, it would be great.
Yeah, okay. And chat window. I don't seem to find it. Okay. Okay, shall we start? So the question number 12, implement the custom layer that performs the layer normalization. So that's where he has written the layer normalization. So we're gonna write the build method should define two trainable weights, alpha and beta, both of a shape in input shape -1. So whatever input shape is the last element of it. We're going to make alpha and beta of that. And the data type is float 32. Alpha should be initialized with 1s and beta should be initialized with 0. So that's where he has defined the class. And then he said, whenever you define any layer, you need to inherit it from the layer function. And it's straightforward, dunder init. He defined here epsilon, which is hyperparameter, and just call the super dunder init, passed on the stars or coargs to it, and then assign the EPS to the self.EPS. And then we have the build function. That's where he said define the build method, and in a build method we are passing the batch input shape, and the last element of a batch input shape is the alpha shape, and self.add weight. So it's the function it's calling add weight. So I'm assuming that add weights is defined here in dot layer superclass, and we just name it. Name is equal to alpha, and so that's how the alpha is defined, and it's initialized with the ones. So this is interesting. I'm not sure. Anybody have used this add weights before?
That's like a parameter in PyTorch, so it probably just adds
Once.
learnable parameter to the module.
The ones or the alpha? So
Alpha.
Yeah. So alpha is we are defining. That's what he. So in a sense, like it's interestingly, it's like, you know, we are giving ones as the text. So add weight is able to, I guess, is able to resolve ones into actual integer ones, this string ones into integer one. So I'm assuming with add weights could do it. Anyway, and then beta is same. Beta is add weights is zeros. So all the weights are for a beta, it's 0. And then as you said, that vector will get learned as we go along in a layer normalization. And interesting part, I think in layers was he mentioned that in the last week, we discussed the build method, super build method need to be after you have initialized your own variables. So this must be an end. Oh yeah, he said here, must be an end. So that's that, build method defined. And then the next one is the call method. So I'm going to read the question. The call method should compute the mean and standard deviation of each instance feature. For this, you can use tf.nn.moment inputs x is equal to -1, keep dimensions is equal to true, which returns the mean and a variance of all the instances. Compute the mean root square of the variance to get the standard deviation. Okay. And then the function should compute and return alpha by x minus, I think maybe x minus mean and divided by standard deviation plus the beta, where x represents the item-wise multiplication and is smoothing item. Small constant to avoid by the 0. Okay. Yeah. Which one is small constant? Small constant probably is the beta, I guess. Let's come in here. So he said you can use this moment function, and then x is whatever value get passed. X is x -1, keep dimension true, and this is going to return mean and variance. And we're going to return, call function is going to return self.alpha multiply by each instance minus by its mean, which we calculated here, divided by standard deviation, and divided by standard deviation. Actually, that part was the small the portion where he said where and is smoothing term. So smoothing term is, I think it's the epsilon, the value 0.001, which will avoid multiply divide by 0. So that EPS epsilon value is there, and plus the beta. So it's basically alpha multiply this term plus beta. That's the call function is going to return. So that's that. And ensure that your custom layer produces the same or a very near the same output as the layer normalization. So normal layer normalization. Okay, I think in the next stage he has tested it in a question number C. So let's try here. Where is the, okay, I'm gonna just say here. So custom layer, where is custom layer is our layer normalization, which we define up here. So instance of that. Layer normalization as a keras instance defined here, and then we're just finding the absolute mean error between the keras layer and a custom layer, which turns out to be 1.1 into 10 raised to power -7, which is very, very small number. So that point proven that whatever you're doing is that it's the layer normalization which you have defined here is more or less similar to the existing Kira's layer normalization. And I think because we are not inheriting, we are inheriting from layer. So I am just, question I have is like, where did we do the learning of the weights as such? We didn't do any learning anywhere.
I think here it's the initial weights itself, the default weights.
So default weights of layer normalization, which we defined, and the Kira's is
Yeah, apparently
little
they're same.
because we did this. It's gonna put them between 0 to 1.
That part would be the same for uh, our implementation and their implementations. That just calculates the mean and variance for the features we have, right?
Yeah,
So the
and
input is the same. So that will also be the same.
yeah, and that's the reason the difference between the two is negligible because of this.
Yeah, so the only difference that so mean and variance has to be the same. So because it just calculates the mean and variance of the inputs that we pass.
X, and that is same. Yeah,
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 that has to be same. The only difference that can come is the initial weights that alpha and beta have,
beta have, yeah,
because there's no learning in this, right?
correct. Oh, so alphas are ones and betas are zeros.
Yeah, so it's probably just calculation precision error.
Yeah, yeah, correct. Okay, so that was straightforward. Shall we move on?
But
Yep,
they do
that's close
something
enough.
else. So they are
Okay, so that probably it says to be extra sure, let's make alpha and beta completely random and compare again. Okay, so random alpha, random beta, which is that's probably defining shape of x. So random alpha, this is a variable defined. What would be the shape? So these are the values, whatever coming from
that's
this.
the size of the features, the
Yeah.
number of features. Yeah.
Okay. Yeah.
So
And
even here he sets the same weights for our layer that we just implemented and the default layer norm, and then he calculates the difference. So it's
oh yeah.
even closer.
Okay. Yeah. Because these are random, but now we are using um yeah. So the alpha betas are going at the same values. Before it was ones and zeros. Yeah. And the difference is again it's 10 raised to power minus 8. So it's very small difference, negligible.
And one
Or
more thing to add is I think layer norm and batch norm implementation is probably exactly the same, except that the axis of calculation of the mean and variance is different. Here we are calculating the mean and variance for the features, whereas in batch you're calculating it across the batch, across the examples.
so in a layer normalization, we create for the batch or
No,
or
in
other way
batch
around.
normalization, you find the mean and variance for the batch, and
Yeah.
here you find the mean and variance for each example, like across the
Yeah.
features.
What do you mean by across the features?
So if suppose a layer has 5 inputs, x1, x2, x3, x4, x5, so you
Mm-hmm.
calculate the mean of x1 to x5 and the variance of x1 to x5, and
Mm-hmm.
then you, for each of them, you subtract the mean and divide by the standard deviation, and then the alpha beta comes. So that's how you do layer norm. Whereas for batch norm, the mean is calculated for x1 separately, for x2 separately, and that mean is for the whole batch. What is the mean value of x1 across this batch? What is the mean value of x2 across this batch?
Mhm.
And then again standard deviation. And then for x1 you do the transformation, x1 minus mean by standard deviation.
Mhm.
Everything else is the same.
Okay. And in the layer normalization, you do across the feature, as you said.
Yeah.
You just take all the features together. Okay.
So it is independent of the batch. The only that particular data point matters. It's not depending
Okay.
on the batch.
However, when we are processing a data, it's going in a batch. So are you saying when the next batch comes in, the mean will get added of the features? So let's say you have a batch of 32, you calculated mean and standard deviation across the
Mean
features.
and standard deviation are calculated for each example separately. For each example across the features, you are calculating mean and variance.
So in the next time when the next batch comes in, you will scrap the
Yeah.
old one and calculate it again.
Yeah. It's not even in the same batch, each example will have separate mean and variance, right? Each image will have as a different mean and variance. So each image has its own features, right? I mean,
Yeah,
each example has its own features, right?
yeah.
So their mean and variance will also be different.
No, I'm not getting it.
So suppose uh, so suppose a particular data point has 5 features: x1, x2, x3, x4, x5.
Yeah,
And so each data point in your data set, each row in your data set has different values for x1 to x5, right?
correct. Yeah,
Each row has different values for x1 to x5. So each row has different means and different variances.
yeah, 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 yeah.
And then you use those mean and variance to calculate, to do the layer normalization. So
Okay.
x1 minus mean by variance. So this calculation is different for each row.
For each instance.
Yeah.
Okay. Yeah,
Regions. Yeah.
yeah,
Yeah.
yeah. Makes sense. Yeah. Thanks for explaining it. Okay. Anything you want to add, Arto? And welcome, Maria.
Yeah, sorry.
No, it's all right. We are doing the practical bit. The last question.
Okay.
We just running it. It's all we did was, I think in this question 12, he asked us to write the layer normalization. In the chat window, I have that Collab notebook sent, so you can open it on your PC. So all he has done is he wrote the layer normalization, the custom layer normalization, and then just comparing custom layer normalization with the Kira's layer normalization. And
So does he talk about when you should use layer norm versus batch norm anywhere in the book?
no,
Okay.
it's I remember you mentioning it before as well, Gautam. And
Yeah. It's used
I
in
think
BERT actually. Yeah.
the
In the
layer normalization.
transformers and all.
Mhm.
Was that?
You're
Yeah,
saying
layer
it,
norm. Yeah.
uh-huh. No, in this book he has covered everything, but not in quite a lot of detail. And especially, you probably have observed this chapter was quite dense, but the next chapter is dense again. The whole vision was really dense. It could have been easily multiple chapters.
Well, I'm not sure there is a definite answer to the question which kind of norm would you use, given that you can apply both, because in some cases you won't be able to apply batch norm when you want to train on like very small batch, and yeah, so I was trying to find the answer why exactly layer norm is used in transformers, and I really didn't find it yet. Some like definite answer to that. So well, maybe because just there are cases when you want to use transformer with a really small batch size, and in this case, batch norm would work worse. And in the paper which introduced layer norm, it was, I think, before the transformer architecture was introduced. And there are like some mathematical difference between the layer norm and batch norm in terms like what invariances they introduce, but also it like didn't give really like comprehensive answer to what are the cases like when one or other might be better. And basically, you know, there is that discussion that the motivation behind batch norm in the original paper which introduced batch norm was not quite sound mathematically turned out, but still it works. And I think that all this stuff is much more empiric than like theoretic at the stage.
Yeah, I remember Jeremy talked about that. The reasons for why batch norm works was not what they put down in the paper.
Yeah, so like that's an interesting question, and it might not have like really well-defined answer. But I'm not sure. Maybe there is an answer, but just I haven't found it.
And you're saying the question you're saying, Arto, is difference between the two, like why we use one over another.
Yeah.
Is that correct? Okay, yeah. And then you're right, Gautam. I actually, there is a paper on the batch norm, as Arto said, it works empirically, but I think the suggestion was something to do with the covariance, I think. So they use one term, covariance, and then they say, oh, that's get reduced and blah blah. And there is another paper, they showed it that that's not the reason. So they refuted that claim. But as we said, like it works. We don't know why it works at this stage, or perhaps there are papers which we are not aware.
Yeah, why it works? It's basically because it stabilizes the training and helps to avoid vanishing and exploding gradients like this. So that you can stack more layers, and the network, like the gradients would propagate and back propagate normally. But yeah, so more like if you want to go into more theoretical depths, that might not be very easy with those norms.
Yeah. Okay, shall we move on to the next one?
Yep.
Okay. All right, so train a model using a custom training loop to tackle the fashion MNS dataset, which we used before. Okay, that's the one. And display the epoch, iteration, mean training loss, and a mean accuracy over each epoch updated at each iteration, as well as the validation loss and accuracy at each end of each epoch. So what's the difference? Train a model using custom training loop to tackle the fashion MNIST. So all he's trying to do is some customization. Now, I try running it. So I would ask you guys to run it as well. Do you know what is a T range? Have you used it? Do I need to, because it throws in an error for me. T range is not defined. And I was looking up above, I couldn't find it. So maybe it's some library. Or maybe you give it a go and see if it's working.
It looks like range, but as a TensorFlow function, so that it can be part of the. Okay.
It's not the. I was just looking at the T range. It doesn't do anything. Range.
Just add TensorFlow as well. Or maybe you just accidentally pressed T on your keyboard.
No, it's twice. Can you?
Oh,
that's why I want you to open the.
Well, it looks like it is used to display progress.
Is it
So
maybe?
you see there is that description parameter which is not present in regular range function, I guess.
Sorry, I missed it. So even if I open a new, let me.
You can remove this T letter and remove the this description, and it should run, but it probably will not print anything.
it looks like it's part of the TQDM package. So you have to
Yeah.
do from TQDM import range.
Okay. From TQDM. Is that this code? Let's see. Oops. No module TQDM. No.
You said TDQM, TQDM.
QD.
Yeah.
Okay. Random batch is not defined. So random batch. We can find random batch. It must be. Okay.
You probably should rather use this Collab search. It should be defined somewhere.
Yeah. It's maybe up here somewhere he's defined.
You can click edit.
This guy?
No, edit in the top bar, in file, edit, next to edit.
Okay, sorry, yeah, and
find next here, right? And you can search for definition, like where
yeah, it's defined here. You're right. Yeah, here. Okay. So we go back down here. No. And yeah, here. So okay. Oops. Order dict is not defined.
You probably didn't run some import cell.
I ran the topmost. So what he has done is, because this is a whole exercise, 10 questions we already.
I see.
So I did this guy. So I didn't want to go every single cell because they were already done. So let's see if we can do it. batch. No, I'm not looking random batch. I'm looking. Order dict.
Yeah, that's the one. From collections, import order dict, the first one. Yeah.
Where? Oh,
Yeah, that's the, yeah.
okay. So let's take it down to over.
He decided to do it quite a weird way to
Yeah.
stick this imports into like training loop definition.
Yeah. Okay. So let's. This is training. Sorry. Let's see what we were supposed to do. Okay.
It
So
looks
it's saying
not working properly.
Yeah, I think so. There's another thing called TQDM notebook. So you should have imported from that. So this is a notebook. Yeah.
There are TQDM auto which should like take care of this probably, but
yeah, I think it's gone into a big loop. If I can interrupt. Come on. Any control C would work? No. You know,
Runtime interrupt kernel.
yeah, well, it's not clicking there.
Oh, okay.
It says because I think it's gone into. Okay. Not really interrupt execution. So this is control this and then. Is it MI? I probably need to exit page and then do it again. That will be quicker. Okay. It's connecting. So I think that part was done. Let me quickly run this. So we had two guys. One was missing and
while we're waiting, Gautam, that course you proposed in the KS 224N thread,
Yeah.
did you start to follow it already?
No. Nope. Nope.
It
Not
looks
started
pretty interesting. A lot of
Yep.
stuff there.
Yep. It would be
And
great if we
it
can
seems
do
like
this.
there is quite a lot of people interested in that course.
Yep.
So it probably, how does it work? Who will start the study group? Or
So usually Joseph is the one who organizes everything. So if we can get his attention, and I don't think he has seen the post yet. So he will organize everything. And so first we'll decide. So people can volunteer to lead each video, like each of the lectures. And once we have volunteers for everything, then we'll just start off like every week with one of the lectures.
that sounds interesting. It should be, I believe it rather practical, right?
Yeah, there's a practicum video after each lecture.
Yeah,
with just
that's
code
nice.
and
I think that like doing it in practice makes it much more useful.
yeah.
Actually,
CS224 was very theoretical for me. I did not do any of the homeworks.
Yeah.
It's the course you proposed, Gautam?
Yeah, so there's this channel called CS224, and you can check it out there.
the only problem, I think a couple of weeks back, Gautam, somebody asked Joseph, and he said like he's not interested to start or a host. He said we are more than welcome. Somebody else can start. So I guess it's the somebody.
Who is not interested?
Joseph, he said like he's
Oh.
busy, so he won't have much time to.
I mean,
take.
he does not have to host. He just has to like get it starting, like yeah, the logistics and stuff. I think people will be willing to lead the sessions.
Yeah. Yeah.
Then is one change you have to make here is tqdm dot notebook import t range.
Okay. TQDM.
Yeah. Dot
Yeah.
notebook.
Dot notebook.
This is what messed up last time. Yeah.
Okay. Yeah. This is still connected, but I'm not sure what's going on. It's still running. I didn't run any other. It's still running. I'm not sure. I interrupted as well. Maybe the last one didn't get. So maybe I need to terminate from here.
You can do factory reset runtime there to make sure like everything is clean.
Okay. Factory reset runtime. Let's do it. Yes. Let's run it now. Guys, connected. Okay.
And
That's
that
the
course
one,
is
and I
very
think
intensive
we
on
had,
PyTorch. So you can learn PyTorch really well. Yeah.
Yeah, PyTorch would be much more handier for me because like now I have much more practice with PyTorch rather than TensorFlow, and I noticed that some parts of Google itself switched to using this JAX or YAX, I don't know how it's pronounced, based libraries. You know, there is Flex and Tracks. And I'm not sure if that's a sign that like TensorFlow might be like changing even more soon. I don't know.
That will be another framework for us to learn.
Yeah. But I like have a look at that tracks library, and for like my personal opinion, the code is kind of ugly. So I like didn't had time to dive in really yet.
So is it like functional style or something?
I like no, I don't think it's more functional than anything else. You know, it's just a bit different and like syntactically. So yeah, I don't really have to say much about it because I didn't really use it. So, you know. There is that NLP course on Coursera, which is based on that library, and maybe that can be like a point to start with it. But I also didn't do that course.
Is it the NLP specialization?
Yeah.
So that's based on JAX? That's TensorFlow, right?
I'm not sure the all course is using that, but the transformer related part is using this tracks library, which is like one of the libraries based on JAX. And I think it's developed in Google by the guys. I think that Lukas Kaiser group.
Is this called Ajax?
No, just JAX. JAX. JAX deep learning or something. Yeah.
Oh, what's your stance?
Yeah.
Okay. Or maybe I think okay. This course will explore. Do you want me to read it quickly, or is too long?
Oh, I think that's like really. It needs some time to dig into to understand what is like the benefits and.
Yeah. Okay. We will read after this. That's
Yeah, but I just noticed that like some parts of what comes from Google lately is based on it, not on TensorFlow. For example, that long-range arena paper, which was comparing efficient transformers, they were using JAX.
Which paper is that?
It's called long-range arena.
Okay.
I can send a link if you're interested. It's basically they introduced benchmarking framework for efficient transformers.
okay. Shall we go back to this? Look into this code. So it's saying train a model using a custom training loop to tackle the fashion MNIST dataset. So basically that's our MNIST fashion dataset. We load it into X train full and Y train full, and from X train full we created X valid. First 5,000s are valid, and X train is the rest 5,000 onwards, all the training. And the model is sequential model, flat input 28 by 28, activation value. Last function is softmax. 5 epochs, 32 batch size we're going to do, and steps, these many steps, I think is 1700 something. And we have optimizer of NADM with a learning rate of 0.1, sparse categorical cross entropy as a loss function, and mean loss is, I think it's gonna do the calculation in the end, I think. So that's the training loop. Let's try to go. What was T range? Do you have any idea what was T range, by the way? It's
Prints the progress.
this way.
Yep.
Okay, so it's gonna print the progress 1 to epoch 5, which is 1 to 5 epochs. Okay, and then within it, did it do again, and that's for the step. And then I was saying there are 1718 steps, so that's what it's doing. So this loop is this, and then we go through our steps, and we have the batch, random batch picked from the X train, Y train, and TF dot gradient tape is the, I think it's the gradient which keep track of a gradients. And correct me if I'm wrong anywhere, because I don't have much idea myself as well. So then we are getting the prediction from a model. So I'm not sure, where did we define a model? We define a model here. Where is a custom loop? Is this the custom training?
Yeah,
Oh,
that's the training loop. So this is something that you always do custom in PyTorch. In PyTorch, you always write your own loop Whereas in TensorFlow, you can just do model.fit and
Yeah.
all that. Yeah. But in PyTorch, we don't have that.
Yeah,
We have to write
Keras
everything.
is like closer to FastAI or PyTorch Lightning than to PyTorch itself.
Okay, so here we have a loss function. We got the loss and we stored in the loss, and then we keep on adding a loss in here, like add n. So these steps, you're saying in PyTorch we do this manually. We calculate all the losses and add them ourselves. We have to do these steps where Keras, yes, in a Keras, we just do the fit method, and then in the end, it gives us everything.
Yeah, so
Yeah,
basically what you do in here, you implement in your own fit method.
Yeah,
so
exactly. But my question is,
Keras does internally, but also with callbacks and stuff.
So in the PyTorch, you have to do it when you collecting all the mean. You're collecting all the losses here in these functions. So you have to do these steps in PyTorch. Is that what you're saying?
Well, yes, if you are not using some high-level API like FastAI.
Okay, yeah. And so this is the, I think, collecting the gradients, and then optimizer apply gradient. So this, I guess, getting applied. So it goes through weights getting updated, I'm assuming here. So all the weights for each batch get updated, and then I think we are going in each step, and that step would be there's a part of a step, and then steps are in each step we're going to have a 32 batch of 32. Yeah. So
what is the model.losses? Anyone know?
where is the model dot losses?
So you add the model.losses to the loss, to the main loss. Yeah, that one.
That probably is the part.
That is for regularization. That's it would probably be weight decay added in such way. When you define your model, you can define the extra losses, and for example, weight decay is defined in this way. So it will like when you run a batch through a model, it will add accumulate every weight norm multiplied by weight decay and add this to model.losses.
But I think this is done automatically in PyTorch, right? You don't have to add weight decay loss separately.
In PyTorch, I think it is done by in optimizer. You can add a weight decay parameter to optimizer, and then it applies weight decay.
Yeah.
Okay.
And another difference is in PyTorch, the gradients are recorded by default. So if you don't want them to be recorded, you do torch.noGrad. Whereas in TensorFlow, it looks like it's the opposite. So you have to manually say that I want the gradients to be recorded. So that's what with tf.gradient tape as tape. So whatever comes under that context manager, the gradients are recorded. Whereas anything outside that, the gradients are not recorded.
Not recorded. Yeah, that's the assumption, I guess. It's probably, I think, once you go through it a few times, once you do it, then you'll understand. Okay, so again, this piece of code, I don't have much idea, but my guesswork is like a model has, these are the variables you defined within a model. It's going through one by one and checking variable constant is not done. And then we'll get assigned into, not sure, variable.assign.variable.constant.variable. I'm not sure.
You can limit norm of the weight, and that's a part which takes care of that.
Second, what exactly is this part is doing?
You can set constraints on the norm of the weights. So you can bound the weights to be inside, to satisfy some constraint. And if you did it, this part probably takes care of that.
Okay, so you're saying the limit on the weights, that it shouldn't go above certain threshold.
Yeah, and if it, you see, if this constraint is defined, then if the variable is out of this constraint, it will assign it, it will constrain it.
Okay.
That constraint is usually on the gradients, right? Gradient clipping and norm limit. It's not on the weights, right?
Yeah, usually right, that's done so, but I remember he was talking about it somewhere in the book, that's another way to regularize your model. Okay. It's just not used very often, I think.
Okay, so next is, I think this is just a function, outside function he has called. Let's quickly find it.
That's a Python object, right? Like a dictionary.
Okay.
Similar to a dictionary, but with order.
Okay. So, yeah, okay. So that status get called, so status is nothing but just the instance of order ticked. And then you say it's a dictionary, but in order, in some ascending or descending order. Correct?
Yeah, it has inherent order in it. Whereas I think the default dictionary is orderless. It does not have a first element, second element or so.
So as
an order, so you want to record the losses in order of the epochs, right? The first loss should be in the first position.
Yeah.
And so on.
But actually, I think now by default, the Python dictionary are ordered.
Yep.
In the latest versions.
Yeah.
Why do you want to keep the first loss? So I thought that's the default behavior. So if you define a dictionary, it doesn't get sorted itself. So because we're going to go in a sequence, and then so automatically it's going to be stored position as it goes along. Or do you want this to your loss need to be like in ascending order or descending order? You know what I'm asking? No. I didn't understand why the ordered dictionary then.
So in old Python, if you add elements in your dictionary, if you add key value pairs in your dictionary and then you ask it to give it the first element, it would just throw an error because there is no inherent order in dictionary. There are just key value pairs. There is no order. Whereas in ordered dict, you can ask, give me the first thing, give me the second thing. Yeah.
Okay. Got it. Yeah. Okay, and so mean loss. So that's mean loss gets stored somewhere, I guess. Fine. Next, I'm not sure whether this mean loss. It's a Kira's library. Mean loss is Kira's library here. So I guess that the loss gets stored, or it keep getting added in here, and it creates it's calculating a mean for you for this step. I guess that's what I can infer from it. And then there is a variable status where loss gets stored. So I guess this guy gets stored here. Yeah. Okay. And the last thing is for the metric and the metrics. So all it's doing is nothing but metric y batch, y predictions, and metric name. What the metric name would be? The cross entropy loss, which gets stored in here. And do you know what's this? Step.set postfix is equal to status. What's this set postfix would be?
That probably it assigns like some text to TQDM, this to progress bar.
The progress bar. Okay.
Can you point your mouse on top of it? There was some box that came. Yeah.
Okay.
Set modify
Postfix with automatic formatting based on data type. Set modify postfix additional stats with the automatic formatting based on data type.
So something I noticed is the loss gets overwritten every time, right? If you see status loss equal to the loss, so what that will just get overwritten for each step. So I guess this is doing something to retain that. Not sure.
It just will be displayed near to this progress bar. When you run this, we will see what it does.
Let me run it. Actually, there was a bar before here, but
Because otherwise,
it's gone. So
the need for ordered dict, I don't see the need for ordered dict if you're just rewriting every time.
okay.
Yeah, the need for ordered dict is because he uses it in this bar, and he wants to be like key value pairs displayed in order.
Okay, my apologies. I think I got into a wrong box. I was explaining in a wrong box. I think it should have been this guy. It was the next one, which I. This is the next question. Yeah. Hang on a second. No, I was supposed to be running here. Yeah. So actually, they look same, but my apologies. Like we start discussing something slightly different. It should have been here. So this is because I ran it. That's why I know it. So we did this. This was good. Actually, yeah. So it wasn't any different. I think we were on the right time. So this is what we were discussing, that set postfix. So this is the value, or maybe this loss is equal to status loss. I'm not sure. Yeah,
the status is all this loss, sparse categorical accuracy, val loss, val accuracy. You see, all these values are assigned to status dict. It's a dictionary.
Yeah.
And it is displayed after status, like this progress bar.
Yeah.
And that this set postfix method does just that. It takes care of displaying and updating this stats after a progress bar. And he uses ordered dict because he wants always the same order for this for keys in this dictionary. And in older versions of Python, it would be like in random, or dictionary would print his keys in random order. but yeah, now you can just use a regular dict and it would work the same.
Yeah. So these guys, this guy and this guy and this guy, they are getting printed here. So every time as we go step by step basis, it's gonna keep on overwriting and then keep on printing it. So that's why it's just a status.
Yeah, and accumulation is done by this metric
name, yeah. Okay, and so set postfixes, you're saying that get displayed in this form in here. So finally, we have the metric in mean loss plus metric. So this is keep on finally getting added in here in a metric, and reset status, I guess. Yeah, so this is for the for each step, I guess. Oh, no, not each step, but okay, so metric in metric loss plus metrics, mean loss plus metric, and a reset state. So okay, so what any idea? What are we doing here? Mean loss plus metrics.
Yeah, you have defined some list of metrics which you want to be calculated, and you need to reset states of all metrics after each epoch.
So if I say Control C, Control F. We haven't, I mean, like metrics. So metrics is defined this sparse categorical accuracy. Oh, so this is the object defined for the Kira is sparse categorical accuracy. So we are adding the loss with the metrics and storing in a metric.
You just iterate over a list of different metrics, and this add, as when applied to lists, it's like you concatenate this list together, and then iterate over all of metrics and reset its states. So it's done. It's like just like flexible way to add more metrics here. You can have multiple metrics in this metrics list, and you will have them all reset after each epoch.
For each epoch.
Yeah.
Okay. All right. I think it's need to be debugged just to see step by step how it's working. But yeah, thanks for the explanation. Okay, so that's that. Any question on this? We probably do quickly the next stage. Next is nothing but same loop, but try the different learning rate and different optimizer. So that's pretty much, I guess, we are, where is the learning rate? The optimizer would be here. So we are using, oh, so what he has done here is it's an interesting piece of work. So let's quickly look. What he has done here is he has defined two different layers. One set of layer is this, he calling as lower layer, and then another set of layer is where the activation in lower layer is ReLU, and upper layer is softmax. So, and then he combined both. So there are first 100 layers, we're going to have a ReLU, and the next 10 layers, you're going to have a softmax in the model, sequential model. And interestingly, then he has two optimizers. Lower optimizer is SGD. So for 100 layers, we're going to use the optimizer of SGD. And the last 10, we're going to use the NADAM. And this is interesting. Like, I didn't know you can do it. And that's all he has done here. So let's run this. Let me run through it. I'm not sure what we're going to get out of it. And the one thing he said, different learning rate. So that's all I have. Oh yeah. So when you're defining your optimizer SGD here, 10 raised to power -4, and here 10 raised to power -3. So different learning rate. So that's the interesting part. And then the rest, I think this is going to be more or less same. I think the only difference is here, where he has applied custom lower optimizer and an upper optimizer. I think the rest should be the same. Yeah, so this is same. The same. I don't see any other difference except these two lines. So this was interesting. So let me run this quickly to see. So we had 110, and before we had 110, same. So let's see what was the final validation accuracy was 0.86, and this was 0.869. So let's see what different learning rate, different optimizer, if it gives us slightly different improved accuracy or not.
So I think this is the case where you have to have a custom training loop. So you can't just do model.fit and have two optimizers and two learning rates.
Yeah. So yeah, that definitely. Here he is doing a very customization where you have different learning rate, different optimizer you are using. So definitely, yeah. So two different things. So obviously, yeah. Okay, so we're 0.8. So we are supposed to be over 0.869 and 0.87. I don't think it made a huge difference. 0.81 and 0.81. Yeah, it didn't make any difference.
It's actually done for just demonstration purpose, not to like improve training.
Yeah. Okay, yeah. So it didn't make much difference as far as improvement is concerned, but it was interesting. Yeah, I'm glad we have done this. So this guy, it's interesting piece of work, I guess. And most of the time, you can just take it and start using it and just do small tweaks to productionize it, I guess. This is the template. We can take it and start using it. Okay, so that's that. So we finished chapter 12, and then we are over 2-3 minutes. So we all good. Next week we'll start the next chapter, chapter 13. And what's chapter 13? Yeah, loading and pre-processing data in TensorFlow. TF records. Oh my God! So this is going to be interesting. Anyway, thanks very much, everybody.